Just 5 minutes.
Sylvain Bellemare will teach you how to use Docker.
Thank you. I guess teach is a bit too much for that. Okay, so hello. So I'm Sylvain. First, I want to thanks to Valentin and Philip, who are the main organizers of this PyData conference. I joined the Berlin PyData group a little while ago, and they were very welcoming, so thanks to both of them. And they also encouraged me to give this talk. So then PyData Berlin, PyData community, and to all of you for attending. I hope you'll be happy with the tutorial and that you will learn. So a few words about me, maybe. Yesterday I thought of telling you I live in Berlin, and I thought it was boring. And then I looked, I thought I just live in the universe, it's a bit more interesting. And I thought, that's like, it's getting boring too. And then there's apparently this multiverse or this in physics. So I thought, well, I found that the ultimate multiverse is a pretty cool theory. I invite you to check it out if you have some time, at some point. No, but I live in Berlin. I'm originally from Canada, Montreal, but I've been living in Berlin, working as a software engineer for 3 years here. I have a bachelor in computer science with sort of a kind of minor in physics. The university didn't have a former minor, major kind of thing in physics. Well, major, yes, but not minor, but I had many courses in physics, so that's a thing. I was heavily involved in all kinds of undergraduate research assistantship, which is kind of why I'm interested in data science. Because I'm not a data scientist, I'm more just like ordinary software engineer. But in the course of my studies, I was involved in some computational high energy physics research assistantship with some fine mathematical packages called fine arts, and then some NLP automatic text summarization thing. But then from then, when I started working, I've just been working with Python, Django, a bit of Elasticsearch, RabbitMQ. It's kind of standard tools that are used nowadays, I think. And then I got also a bit into DevOps, so SaltStack, and then lately Docker. A quick note about this, the DevOps work, is like, because that's the angle I'm approaching this whole thing. It's like when you work as a software developer in many companies, you're a bit left, especially startups, I think you're left to yourself. Like, we have a sprint, you need to do these tasks and you need to produce and all that. And it's often the cases that, the dev environment is sort of kind of working, and you ask the colleague, it's like, I don't know, for me, I did this command and it works now, and they don't touch the virtual machine, hoping it stays like that. I've seen that a lot, actually. And it was last year, then the guy who was responsible for our VMs was in parental leave. And my computer had a hardware crash, and I just had to install the whole development environment on a new machine. And I was kind of a bit stuck, and then I decided to learn how to do it myself. And I use Vagrant and VirtualBox and SaltStack. And since then, I'm kind of hooked on that, because what it gives you is like you really feel autonomous. At least that's what for me it brought, and that whatever happens, I can focus on my development task, and if my development environment somehow is broken or somehow, I sort of know how to fix it. Plus, this knowledge is useful even to help people in staging and production, the DevOps people. So I think it's a really worthwhile investment to learn these tools. So the next thing now is this tutorial obviously will be focusing on Docker. The goal of the tutorial is obviously just to learn Docker, to learn to use it. And I'm also a beginner with Docker, maybe just using it for a month and a half or so on a part-time basis. So that's really the focus. I had initially a long-term goal, sort of like for this tutorial, to at the end have a notebook fully set up that runs in a container, plus using, let's say, something like Blaze, and you have a few other containers in which you would have a few of these data storage technologies, like whether it's Spark, a database, and just to play around with that. But I think it's going to be a bit too much for this tutorial. But we'll see, depending on how it goes. And you're always welcome to interrupt me and ask me questions at any time. I'm fine with that. The tutorial approach, yeah, this is very important. There's something I called it Feynman's Babylonian mathematics. If you look this up, I don't know if I'm going to be able to go on the internet, but it looks like it. It's a video. The thing is like, it's a Richard Feynman, he gave some lectures in the 60s about it's something like called a messenger lecture at Cornell. And it was Microsoft, they bought the rights, and now they have this thing called the Tuva project, and they have all the lectures available. It's also on YouTube. And this is just an excerpt in which it was something called the character of the physical law. And there's a talk where he talks about the relationship between mathematics and physics. And if you listen to that, the gist is that there's a point where he mentions something, what he called Greek mathematics versus Babylonian mathematics. And it's like very interesting to see his point of view that, in brief, what it is, it's like Greek mathematics was known like that they built on fundamental axioms. So now we're learning Docker. That will be the analogy here is like, okay, what is Docker? You know, it's okay, we're talking about Linux kernel, LXC or whatever, you know, and then you just build your knowledge from that up, okay? In contrast to Babylonian mathematics, where you just like, okay, I know maybe how to use Docker for that. I know this part of Docker, and you just like a puzzle, make your way around. And at some point in the end, you may arrive at the same place, but there's no correct path. And now I'm mentioning this because in a tutorial like that in 90 minutes, and it's a short amount of time, plus I'm not skilled enough in sysadmin and DevOps to explain you what Docker is, right? From the ground up, like really like fundamentally how operating system works and so on. So the approach I'm taking is just we're learning to use Docker on the command line, doing things, doing examples, and from that, around that, some knowledge will incrementally grow, you know? But there's no like correct path, like working again from fundamental axioms. So that's why I pointed out this this tutorial approach of Feynman Babylonian mathematics. And I invite you to look at the video. I think it's very interesting because he goes in very precise details about this comparison. Rough outline of this tutorial. So Docker installation, Docker Hub. We'll talk about Docker Hub, which is kind of GitHub if you want for Docker images. Talk about Docker images, Docker containers, and then linking the containers together, managing data in containers, and Docker Compose if we have enough time. So look, for instance, what is Docker? You know, I looked this up, and this is what Docker says on their website, which is like, Docker is an open platform for developers and sysadmins to build, ship, and run distributed applications. Okay. I mean, that's why, you know, Babylonian mathematics, for me, that's like, whatever. I mean, it's like, because otherwise, if you really want, one way to maybe that it makes more sense that I saw someone, what they say is that Docker sandboxes a process. So a Unix or Linux process, that's if you're running whatever, like the ipython notebook or a web server, a WSGI server, then you're sandboxing that process, and you're able to have many of these processes sandboxed and sharing some resources of the base operating system. But that's not the direction in which I wish to go right now again, so I just want us to practice using it. So, okay, installation. So who has not installed it, let's say, and wants to install it? Okay, you're on the Mac, and so maybe then let's... Okay, installation. So if you're on the Mac, like there's two main ways that you can go about. Fundamentally, in the end, it will be like running on a virtual box. Yeah? So you need probably to have a virtual box, I guess, installed, right?
Installed? No, you don't need
it installs it for you, I guess, or something.
to take the DMG and you're done.
Oh, okay. You see.
You take boot to Docker, because if you install VirtualBox, it might not really work well. It's bundled with.
Okay, okay. I'm sorry, I haven't installed for a while, so okay. But did you try just brew install boot to Docker? Because actually this works usually.
Okay. It didn't work with me.
Didn't work.
Don't use brew.
Just download the package and then you don't.
So did you go on this website and you tried following the instructions and?
Yes, exactly. That works. There's that one.
And I will do that.
Yeah, you're fine?
Yeah.
So you guys are fine that I go on? Yeah? Just a quick note maybe about that, that if you're like a small trick, if you're on the Mac or some other machine where you don't have Docker, right? Like a quick parenthesis, right? Like the thing is like for Linux, it works like natively because this thing Docker is based on LXC as far as I understood, which is specific to Linux, and Mac OS X, the operating system does not have that. So that's why we need to go around that using very lightweight virtual machine. You can use Docker machine as well, where you create a Docker machine like that. But I don't want to confuse you, but then just to... And this will instantiate a virtual machine with Docker bootstrapped on it, and then you SSH into it, and you're just like in a Linux environment, and you can then use Docker machine. That's like another... it's not...
Say enter a few times.
No, but this shadow. Oh, okay, yeah, all right. Okay, so installation. Check the installation. Let's do that just to be sure. I guess I don't think it matters much for the tutorial, but 1.6.2 is one of the latest one, I think. So there's Docker help, you can check as many commands. Okay, everyone is okay? Next thing, Docker Hub, to host public Docker images, automated image are built automatically if you hook them up to, let's say, a GitHub or a Bitbucket repo. I mean, this is cool. I don't know if you've looked at that. I encourage you to, if you haven't, you can sign in. You can actually do that, I think, even through the command line, just by doing Docker login, and then you enter your credentials there. Or otherwise, okay, because one nice thing with Docker is that you can share the images, which is okay. Let's say we search an image. So there are many images already publicly available that you can benefit from. So, and by registering to this Docker Hub thing, what you can also do, and if you hook up your images to in the end, what happens is that you set up a GitHub repo in which you put a Dockerfile, and then you link it to Docker Hub, and it will, each time you update the repo, it will build the Docker image for you. But I'll mention maybe more later about that. But if you can register there, that would be nice. And if internet is working enough, then we may be able to try it. Okay, Docker images. Okay, without getting into this, they have a nice. By the way, Docker's documentation is really good, I think. So if at any time when you're on your own, you're wondering, like, I think it's the to-go place before elsewhere, and then maybe. So they have, for instance, they explain here a bit like how, what Docker is a bit like, with these concept of images that are built on top of each other. But, so that's the theory. Now, okay, command line, Docker images. So I don't know if you have used already. You can list images you have on your system. If you have not used it before, you won't see anything. For instance, if I just show you. Okay, so no images. There are like something called intermediate images. So if you want to list intermediate images, you can use the flag -a or --all. We'll show you many more images. There's these non-images, which are, I'm not sure exactly, it's intermediate. I think they're used to build the main image that you have. Okay.
Is there a way to easily delete the image?
Yes.
Just Docker delete.
Yeah. We'll do that in a few minutes. Yeah. Yeah, there are many ways we can go into the order. So let's do first like searching images. So right, you can search the. I think by default the way it is, it's like okay, Docker works with this registry where you can search, store images and retrieve images from. By default, it's Docker Hub, but you can set that yourself in your organization. If you want to use another kind of registry, it's possible to do so. But right now, we'll just work with Docker Hub. So let's say we want to search images. Yeah. Yes, that's what I'm saying. I think it's even open source. It's a Django, I think, based app, and you can host your own Docker Hub registry, your own Docker registry, and you can call it whatever you want. But yeah, it's possible. Yeah. So say we search for Python images, but now because the internet thing here is. There's one thing with Docker Hub, it's kind of slow, even with the good internet connection. So here's probably going to be a bit rough. So I had prepared some examples, so you can try that. I mean, let's try it for fun, but yeah, it's not going to work here. That's unfortunate, but...
Which internet?
Really? Okay, but it doesn't matter. Me, I did it before, so I don't care. So, well, you can try these out. No, but seriously, do it because I mean, this is like. So if it works for you, then you can search. Next thing is like there's some search options. I'm going into the details here. Maybe it's not necessarily like obviously if you're just using it at work, there are many things that you don't maybe mind, but this is useful to know, I think. So this will only displays at least because the Docker images on Docker Hub are like ranked with stars. So you can say, okay, I just want to see images who have at least, let's say, 20 stars, 100 stars. So if you try it, for instance, for Python, I think I have some example here. Like, let's say stars equals 15 or -s 15 for short. Now, let me check. Okay, me it does not work. So. Then you can say no trunk. This will like not truncate the output. That means that I won't say the search, the container, the image ID, which is shortened, will be, I think. Oh no, and this is the description of the image. You'll get the full text. Automated is like some images are flagged as being automated. That means the build of them is automated. It will tell you if you just want to search images that have an automatic build. Now the interesting part with that, I don't know why they did it like that, but it's like, so there are some Docker images on Docker Hub that are flagged as official. So they are maintained by the Docker community or company. And from what it looks like, when a Docker image is like is official, it's not automatic. The build is not automatic. So if you filter out like only for automated images, then you won't get the official images. So I don't know, but there seem to be no way to I just want to search official images. So now I cannot show you me because I'm kind of, but if you just do like that, search automated, then you'll just get the official image of Python that is maintained by Docker itself. So yeah, a quick note. So that's what Docker says about it. The Docker official repositories are a created set of Docker repositories that are promoted on Docker Hub. why? Yes. Maybe a quick note for those using Docker, boot to Docker on the Mac, if you're using it. Sometimes you have to restart it if you switch network. So I think maybe that's why it was not working.
Did you switch to the VBox one? Because it's quite stable.
Okay, but anyways, so if I go this, there's thing that's the official repository is on Docker Hub, and then and if you're really into it, you really want to look at it, there's the repo. You can even contribute to these official images on GitHub, like where they're maintained with the guidelines on how to contribute and so on. You know, this is quite involved, I would say. But still, if you're curious and you want to contribute to official images, it's possible. Okay. Docker pull. Okay, now so searching images. Sorry, it's kind of slow, but so searching images. Now you can pull images. So let's say, well, maybe just. Yeah, probably. But I mean, it's like. But yeah, what you can do, the example I have, you pull BusyBox. I mean, try it. I mean, why not? BusyBox is a very small, minimalist machine for embedded Linux. So just try it. I mean, and I'll pray. No, I don't. But oh yeah, so the search is also now, okay. Okay. So then you can list, you know, I don't know, me, I'm kind of feel close. Oh, okay, now I've pulled, let's say, BusyBox and I'm also abusing here because I already have it, but okay, wow, the internet is like blasting right now. Okay, so then you can list images and you can see, is there a way that I can move that it's not like,
Run higher.
does it make sense if I'm like that?
You can make it so smaller move the jungle. You can push it. You move it up.
Just the bottom.
Okay, but anyway,
Resize the window. Like you can resize the
Just don't use full screen.
to the right.
I'm scared about. Yeah, and then you have to readjust it. Yeah. That's easier.
Yeah.
okay, then, okay. Okay. Okay, cool. So the thing, like, you know, quickly, because sometimes when we do something, especially at work, maybe there's lots of things we overlook, like because we don't need it. And later, like, I cannot find it. And it was like right in your face in the beginning when you learn the thing. So just like when you do Docker images, like what it shows you, you know. So I'll clear the screen and. Okay, the repository name, BusyBox, the tag. So yeah, images are tagged. So they can be a version, as if later we could look at images like Python, so they'll be tagged with the Python version, 3.4.3, 3.4, 2.7.9, or whatsoever. The image ID, the time it was created, and the virtual size of it, okay? Now, what do I have next? Yeah, so run this, Docker images. You can do -a for short or minus all if you want to. So it shows you these, from what I read in the documentation, these are intermediate images. And now Babylonian mathematics, I will not explain you what this is because I don't really know. Yeah, but still, I mean, it's useful to know because as you can see, it has a virtual size. And yesterday I was playing around. I mean, this is very small, but if you like, let's say I have like some kind of SciPy stack related image, it can be quite big, huh? Like 1-2 gigabytes. And then you'll see if you do minus minus all, I can show you on this one. Okay, this is, let's say I'm listing my images, and you see I have like 2 gigabytes here. For instance, ipython SciPy stack. Now, if I do all, and let's say I'll be a freak out my space on my, then you'll see there's a bunch of these none, and some have like, yeah, 1.277 gigabyte, and I think they're like, they support the main image, let's say the SciPy stack, ipython, but that's as far as I'll go, yeah?
Because the images are built as layers.
Yeah, so these are right, they're used to build your,
Yeah, exactly.
yeah.
Sure. In the middle,
Yeah.
only the last one is
Yeah.
named like the head of the
Yeah.
brand, for example.
Yeah, so, yeah, you're correct, yeah. So if you delete the image, these none will get removed. Or if you try to remove one of these, it will probably complain, say, I cannot delete it because.
For me, it
But
looks
yeah.
like these were the previous versions.
I mean, let's stick, let's say, to the BusyBox. You know, we just installed that, and then you can see. So these two, like Alexandre is saying, like they're used to build the BusyBox. Like, yeah, that's correct. I think that's a good example.
So if you build something on top of BusyBox, you would have the second one would depend on BusyBox, so you wouldn't have to install it again, and you would not get another non-image. It would just build on top of that previous unnamed image.
Yeah. So.
And then the Git tree would have branches or commits there.
Something like that, right?
Yeah.
Yeah, so let's say we take BusyBox, right? Okay, if we want to drill down this. So we have BusyBox, none, twice, right? So that will be, if we use this image a bit, that will be, let's say there will be 3 none or whatever. But so BusyBox will be this writable container, let's say, and then none, and then whatever. That's, yeah, good. Okay, next. So. Yeah, you can pull all them. Yeah, let's kill the internet. So you can do or -a for short. So because yeah, images are tagged. Well, I mean the thing is like you can see it. I think if you so we'll do it. So busy. Well, we won't abuse. We'll just do it with BusyBox. So now it will pull all of the BusyBox images. I mean, this can be useful, you know, let's say you just, I don't know, you're testing a bunch of stuff and you need to make sure that they run on multiple Python version, and you want to pull all the images for Python because you want to set yourself to work. Meanwhile, you go make coffee or whatever. So then you do pull all, you know, the Python images. This maybe take a while, no? Even for a small. So let's leave it there. Okay, I won't wait. But after that, once this is done, if you do Docker images to list them, you will see the other versions. Okay. Now, your question. It's very slow response time, sorry. Docker RMI, that's the way to delete the image. So the plan with this tutorial, I was assuming a relatively correct internet connection when I built the tutorial. So it was that then we delete some of these images that we just installed with BusyBox. But yeah, well, let's do it. I mean, you can delete whatever, but if you only have BusyBox, it'll be gone, you know. So I don't know. It's like, well, I'll show you on. I don't want to delete something maybe right now, but maybe, yeah, let's keep this theoretically, just a theoretical thing, because if you delete your stuff, it's not a good idea given the internet. But that's the way to, well, let's see first help maybe. Docker RMI minus. So just remove one or more images. You can force, and then you can, I don't know what the no prune is exactly. Do not delete untagged parents. Well, this is what it is, but I've not used it. So that's the way to delete images. Some example theory here. So you list your Docker images. Let's say, yeah, that was a thing. Let's say with BusyBox. Well, if you have them, if for you it worked, like pulling them all, then you can try. Let's say you delete. You can the way you do it, you specify the container, the image ID. So let's say, which one is the FAF804, RMI FAF804, and it will untag it, and then it deletes the. I guess these are the none images, the one that it uses to build, I think. Right? And then you would see that it's gone. Let's see if I've... No, it's not working. There's a way to list only the numeric IDs of the images. Now, why would you want to do that? I'll show you. That's cleanup trick that I saw. There's this guy, John Willis. He works at Docker and he has tutorials on YouTube, and they're really good. I think they work from the ground up to more advanced topics. So if you have time to spare and you want to know more, I would recommend. So I saw this trick by him on the tutorial. So you can, like, if you have many images and you want to get rid of them all at once, you can do like that. So it will just pass. It just will be a list of IDs, and then you can delete them all. Well. I just kill that. You see it managed to pull one, I think. But let's say I try it here. RMI. Can you see it? So Docker, well, first. Okay, as you can see, it just lists the IDs. Now we want to delete them all. Images. So now I have no more images. Nothing. So that's the way to delete images. Cool. Yeah. Pulling some Docker images. I was very full of hope. Yeah. Did any one of you do that yesterday? Maybe at home or? Cool. All right. Okay. So Docker PS. Now, if this is to list the containers. Now, if I go in the one here, there will be nothing because there's nothing. And you can also do -a all because there's like it will show you Docker PS will show you the active containers, and when you do -a, it will show you also the containers that are stopped. But so I was now let's run something so then this Docker PS will make more sense. Now run is has many options. So first, I'm going super step by step. Okay, we'll take the Jupyter notebook for those who have it. If you don't have it, then just take BusyBox or whatever you have. Because it does not matter. For this example, the next 2, 3, 4, about let's say 3, 4 examples, it does not matter whatever you use. So yeah, you can just do that. Done Docker run Jupyter notebook, let's say, or BusyBox, whatever you have. Nothing. This is not working, you know. Not joking. But if you do docker ps, nothing. Do -a. Oh, I have some more stuff. Sorry. Now I'm polluting the. I think this is. Okay, now this may look a bit overkill, but I'm going very step by step because how do I explain that? But okay, let's keep it like that. So all right, so what we do is like what happens like the container ran and it just exited because it depends on the command that the image has. If the image has a command when it's built, and this one is just I think bin sh and it just exited. Well, bin bash. Okay, yeah, okay, it shows you. You see, so. Container. So right, you have container ID, image, command, so bin bash created, okay, exited about a minute ago, the ports and the names. Name. Yes. Okay, so we could delete this container too, which is docker rm, and you can pass either the name or the container ID. So delete it, docker, Okay, so that's for this. Now we can run in interactive mode. So the flag is -i for short. So what this says, like, keep standard in open even if not attached. So let's do that. You can just do -i if you want to save some typing. So run -i Jupyter. Now it's like, whoa, okay, what's going on? But if you type in, let's say ls, oh, okay, pwd. Oh, sorry.
Sorry, excuse me. The rm command is just delete a container, a running container.
Yes. Okay. We'll come back to it.
Okay.
Yeah. But yes, if the container is running, you need to stop it first. And then if it's stopped, then you can delete it. But we'll come back to that. So, okay, now let me, hold on. Let's restart this one. So, okay, we done doc, can everyone see clearly? Yeah? It's good enough? Now it can appear like, I'm showing you these flags like one by one, but you'll see it's kind of useful to know. So -i, what it does, it creates an interactive, opens a standard input. So now we're in the container actually, and we can execute commands. Like, let's say, okay, where am I? Oh, okay, for instance, Python. It's kind of cool, you know? I can even start ipython, I think. Yeah. Okay. Okay, so that's interactive mode. But this is not maybe very, there's a better way. You can, yeah, we could delete it as well. Yeah, okay, here maybe. Docker. Now I have a few. Okay, I think very often, like, you don't just run and interact. Okay, here, RM if you want it. So to answer your question a bit here, like, yeah, so to delete the container, right, the container needs to be stopped. Okay, the other one, -tty, and then we'll come back. So usually if you do an interactive mode, you also combine with this -t, which allocate a pseudo tty or terminal. So we can try it now just without the interactive, just for the fun of it. So run -t, the container, the image. Now we're in like a proper terminal, if you want, of the container. That's big enough, right? Oh, but now there's a problem. It does not respond because it's not interactive. So you can't. So I have to kill it. So the way to do it properly, if you really want to have an interactive session and to be in the container and to execute commands, is like that. So you passed, right? You guys saw it. So you pass minus. I mean, the short form is -it. You could do -- interactive space -- tty. Sure. So now the same thing. We have we're in the container. So. Okay. Let's say you're, again, because these are like sandboxes, one way to see it. If you want to, okay, you're experimenting, but you don't want each time to delete the container for whatever reason. So you can pass the flag --rm. It will automatically remove the container when you exit. Okay. So.
Guys, there's 30 minutes left, so I don't know if you want to make a pause, break. But
Only 30 minutes to the tutorial?
yeah,
Really?
Tunnel, yeah.
Sure.
Time flies by.
We don't need to break out.
I'm going too slow.
I think we just pull through.
We're in the containers now, man. Let's keep going. All right. Okay, who wants me to speed up? Because I went really. Oh, really? Okay, so you can like automatically have the container to be removed. You can try it. Docker run, and then when you exit. Okay, let's do it quickly. -it, whatever you want. I'm making typos because I want to go too fast. Okay, so I want the container. If you exit, container is, well, it's not this one, it was another one, but it should be gone, you know. That's the thing.
If you don't delete it, it will stay there, no? The soft container.
No, but that was the point of this command.
But the other socket container remains there? Or?
Yes, exactly. That's why this --rm flag is useful, is that it will automatically remove the container once you're done with it, when you exit it. Or if the container exits by itself, it will be removed. You know.
But it removes it from the virtual machine, not data from the hardware. What does it? So
I mean,
you run it and then you remove it from the virtual machine? Or?
Well, we assume, let's say right now, in this context, like if I understand your question, like the virtual machine is sort of like, you can consider like as though you're just on a base Linux system. Because obviously if you go and destroy let's say this VM I'm using right now, the whole thing is gone, you know. Just like if I throw a computer away in the trash. But let's say if we consider a virtual machine to be a real machine, this container is removed from that machine. Yeah.
sorry, another question. Maybe you cover. If I have a socket container, I could attach to it, no?
I don't know.
Okay. I tried that with
Yeah. Yeah. I think you can attach even when it's running.
Okay.
But if it's stopped, I don't know actually.
Maybe I have to start again and then.
Okay. I'll keep going because actually I'm not sure about this question, so I'll leave it aside. Okay, so let's do some real stuff now. You can give a container a name. So you pass a name and you give it, and then it's easier after you can delete the container by its name, and you can do other start it by its name, and so on. So in this example called the notebook, let's say just NB for short, and then you can do that. Now I'll go through. Dockerfile, okay, that's the interesting part. So we can... Now... Yeah, okay, that's... Here's a simple example. So, okay, Docker images are built from Dockerfile, actually. So if you want to build your own image yourself, but usually it's, you'll extend from an existing base image or an existing image, which you can find on Docker Hub. So this is an example of a simple Dockerfile that we extend from Ubuntu. I mean, if you're a really fast typer and you want to type this, you can, and then we will build it. Or you can clone my repo, but now you can give it a shot. Let's give me 1 second here. No. If you go to GitHub and you can clone that repo, I'm sorry I didn't share that yesterday. I was not there. So you can give it a try. I don't know if the internet connection will work, but I would say maybe you just spend 2-3 minutes right now and try to clone this repo if it works. Then you'll have, there's a bunch of Docker files there that you can just already use for the, keep going. So maybe if you can just just clone this, and then we'll go back to this Docker file. Just talk about it. Does anyone need? You have it?
You could just leave it open so we could type it up.
Okay, cool. Why not? Maybe leave the update. Maybe the apt-get update is not necessary because it will be long.
Can you show perhaps for short the comment which you need to open this up? Because that was too quick for me.
This is a file, so if you have cloned the repo, you just open it in a text editor. If you have not cloned the repo, then you can just open any file. And the file is named Dockerfile. Yeah, okay. So that's you need the by convention the Docker file is called Dockerfile with a capital D. So that's the way you need to name the file. Is that okay?
Are Docker images created with such files? So is there such a file behind the Ubuntu?
Yes, every images is like that.
Okay.
Yeah. Now I'm sorry, I'll still on the screen for those who are typing it, but the Python image, Ubuntu image, they have something called from scratch, which they use. But you can, all this you can view if you go to Docker Hub and you select an image, and then somewhere on the website you can, there's a link where you can see the Docker file that is behind. Mm-hmm. Yeah.
So where can I find the repository?
This one. Yes?
Instead of apt-get, could it be using another Docker file to apt-get?
Yeah, you can use CentOS, you can use...
No, I just mean like you do apt-get install Python. I mean, we also downloaded this Python Docker. Can you just connect these two somehow? So you use Python from this one Docker and...
I'm sorry, I don't understand.
The Python Docker image will already have the apt-get
Yeah, exactly. So we already have like a Dockerfile that installs Python with this Python Docker thing.
Or look,
Stuff like that.
Yeah, to extend from the other.
Yeah, exactly.
You could.
Oh, you could. Okay.
for those who have Jupyter Notebook, you can even go, this will even be quicker. I'm sorry, I should have shown that before. If we just want to run a notebook right now, to have an image that runs notebook, you can just do that. This will be quicker to build. But there's a...
Yeah, then just expand it back in.
I'm not sure which screen do you want to see now for who's doing what. So,
I would personally be just happy to, if you could tell us a bit about how you use Docker, what you use it for, and what your workflows are with Docker, because yeah, I can get probably started with all the commands,
sure.
documentation, but getting to know the workflows perspective by documentation is a bit harder, so I would be happy if you could tell us about this.
Well, right now, the usage of Docker I do is right now just on the side if you want. But the goal for me is to then move to use that for development reasons. So when I need to work when I need to develop code for work, for my development environment, like sandboxes. But then the thing is that these images, if you test code in one container and it runs as expected, then you can carry this on to staging environment and production environment. That's the kind of idea in brief. Does that answer you?
Yeah, so maybe if I do Python development now, I usually set up a virtual environment and pip install.
Yes.
And as I feel is a lot of people who are using Docker are kind of using it as an alternative to virtual environments. They set up their OS
here,
and then they install the Python dependencies into it. So they have an isolation.
Yes.
And that is running more smooth than a virtual env that has to be isolated with strange paths and so on. But how do you maintain those environments? For example, if you want to change versions of those packages, how would you do that? Or
you need to rebuild the image each time if you change something. But yeah, I mean that's the thing though. Why I emphasize at the beginning of the tutorial this kind of Feynman Babylonian mathematics thing. There's many angles at which you can approach that, and with this tutorial, I wanted to do more of a hands-on. Even if you don't know why the hell am I using Docker right now in this room now, I mean, it does not matter to me right now. That's the approach I'm taking. I'm actually like learning to use it and discovering how it works and where it will be useful and which kind of type of workflows. I think there are many different answers to that, like depending on your needs. But an immediate need I can see is like if a new developer joins a team and the person needs to join into your, to contribute new code, if you can provide them Docker images to just get started, to have the necessary environment with the necessary architecture, you may need like, I don't know, all kinds of database, this and that, some kind of queuing system, and you have these containers and they're like set up to get to work together. I think you can save a lot of time, and there you have reusability as well. But I mean, that will be the short answer, But I think it depends on people's needs. So, if you don't mind, I'd like to keep with the Dockerfile, and then we can talk later about that without a problem.
When you move from different machines, so if you move from developer to QA to
yes, that's one of the main. Yeah. Yeah. So. Okay, so the idea with the Dockerfile, whatever you have, okay, who has managed to write something or like to clone the repo or? Okay, so we'll keep going like that. So now the goal is that we will run this container, and this container, what it will do, it will run the ipython notebook. So, but you need to build it. Shit, sorry. Okay, So the command to build the container is build. You can give it a name. So let's say I call it just this. You have to give the path to your Docker file. So wherever your Docker file is. So okay. You just give the path to it, but you don't specify the Docker file itself. Is that clear? I mean, a quicker example, just seed into the directory where the Docker file is. If you're already there, it's fine. Then. So now Docker build -t to give it a name. Let's say I'll call it just maybe img. Oh, I'm sorry. I'm just gonna second. Sorry. And then dot to say that here, right? And then you build it. Now for you, it will probably take more time, maybe, depending on what you have installed. Is that clear? So the command again is you docker build. If I make that smaller. Docker build -t and b, or whatever you call it, the name, the tag, and dot. Is that working? I mean, if you downloaded the repo, I recommend you can do the Jupyter one. It should be the quickest, I think.
Ah, okay.
You get the same.
Is that cool? So, did you have managed to build it? You have the image now?
You always need like a parent image, because we now we kind of inherit from this parent image. Can you just install from scratch, or you always need kind of or do I misunderstand? Because this Dockerfile says you have like you say from start from.
Yeah, it builds from the image you specify. So okay, now if you do Docker images, you list your image. So you should have this. Here I have the NB. Okay, so because we're gonna probably run out of time, so let's run it. Docker run. Now -d. Let's just follow on like -d. What's it's in detached mode. And then, sorry, now I'm forgetting them. Just 1 second, I'll go there. Can view the logs of the container.
How do I connect to it? Now I have the ipython notebook running, for example, and usually I would just go to the browser.
Yeah, exactly. Yeah, that's cool. Yeah, here. So that's a command you can run. You can call it whatever you want. -d is for detached mode. -p is to use the ports, whatever ports are specified. If you look at the Docker file, we expose 8888. -v is to specify some volume. So if you have a directory where you have existing notebooks, so if you clone the repo, you can like, so pwd, and then wherever the path to on your host where the notebooks are, if you want to reuse existing notebooks, column / notebooks, and then this was for an, then you need to give the name that you gave to your Docker image, so the tag. So in what I've just built, so docker run -d, -p, let's say, Okay, so did anyone manage to run that? But not exactly. It depends on, right? Like, let me go back to the slide. You can or you don't have to. You can give a name to that container. The important thing is the -d, -p, -v. Even you can omit the -v for this example right now. And instead of Anaconda notebook, you put the name that you gave when you did Docker build -t, that tag. So the name of the image, right?
-v, are you linking a local directory to a directory?
Yes. Yeah. So let me show you. So okay, so now we're running this. Now, how do you go and access that? So depending on, because I run on the, if you're running on bare Linux, then you can just use localhost. For me, because I'm running, if you're running on the Mac, you need the IP of the virtual machine. So you can do boot to Docker IP or whatever you're using, but you need to know the IP of your virtual machine. So you can SSH into it or do ifconfig or something. So now, if I go there, this and the port, No. You need to, that Docker maps the port. So it's 888 in the container, but so I don't, but the thing is, like, for you to access it, you need the port to which it's mapped. So it's 3 through, for you need to check, when you do Docker PS, it will list, and there's a column called port. And then you see, in this case, it's 32768. Or you can do Docker port, and the name, if you gave a name to your container or its ID, let's say I use the ID here, then it will give you the mapping. So 888 TCP 32768. So 32768. Okay, notebooks. So at least if you can achieve that for this tutorial. It's working? Cool. Okay. So now we can create notebooks. Or you can reuse a notebook if you have the repo depending. Let's say, yeah, I had bigger intentions, but I didn't get there, I guess. I don't know, whatever you want. And now like, the thing to maybe link to back to a question, like, for instance, an example of how this would be useful, is that if you have you need to work with the SciPy stack, and Continuum even provides a Docker image, so you can have the entire Anaconda distribution if you want in a Docker container, or whatever you want, ipython as a SciPy stack, or whatever your needs, But now, okay, I don't have an example that's not really the purpose now, but so we have a working notebook. Now, let's say you want to, okay, if you destroy the container and if you're not careful, you will lose these notebooks because they're in the container. That's why the mapping, the minus, where is it? That's why the -v comes into play. So this is on your host, the current directory / notebooks, whatever. You have to provide the full absolute path, I think. It depends on your platform, but let's say you provide the absolute path, the full path to where your directory is, and this maps to your container, and your container is under /notebooks. So, and then, right? So when you work in the container, your notebooks go there, and then they're being, actually your notebooks are actually on your host. They're just, what's on your host is being mapped to the container. Yes?
I make some modification in the container. I mean, if I go there to interactive and I install something, when I stop it, then I lose everything.
It depends. You can use Docker commit, and then you can commit that back to the Docker images. But if you're using, this tutorial like that takes more time anyways, but the thing is, like, you see volume here, the directive volume /notebook, so you have to be careful. The thing is, like, this, whatever goes into that when you commit that container to your image will not be committed to the image. you will lose it. So you need to back this up. But if you save files elsewhere that are not in volumes, that are in the file system, if you want, of the container or the image, then when you commit that container to the image, then it will be saved to the image. Yeah. Are there questions? Yes?
You have this from at the top. Can you have multiple froms? So is it like multi-inheritance, or can you always build only from one?
I've not seen multiple froms. I don't know if it's possible, but I don't think. I think it's only from one. Yeah.
But if you're starting from something that's come from Ubuntu, you got.
Yeah, sure. You can like build that directly.
So quickly to show you, let's say now we can run another container. Or maybe it's useless, but the thing I would have liked to show you like how you can interact with different containers in between each other. So that would have been the next thing. Like then you're in the notebook and you have some data storage elsewhere. Let's say Elasticsearch, Postgres, whatsoever. You can have them in other containers, and you can communicate with these other containers in various ways. One way is that if you know the port and IP, you can just like just as though it was on another server, or you can link the container, and then the link makes it somewhat implicit for the communication from one container to the other. There are environment variables that are automatically set in your, let's say, the notebook container. There will be environment variables for where Elasticsearch is, or if it's Postgres or whatsoever. Yeah. That's.
So still have 5 more minutes. So if you have any questions now. And let's say you're working on a specific environment, and you want somebody else to work on the same. How can you export the environment to a Dockerfile so that you can simply give it to the worker?
That's the thing. So you build your image. In that image you can. One good way is that you use Docker Hub, or you use your own registry if it's private. But to make the answer short is that you would use Docker Hub, and you can use with GitHub. You push that Docker file to GitHub. You set a hook with the.
How do you create the Dockerfile from your specific configuration?
Okay. There's the command Docker history, but I don't know. It won't create it. Let's say this Jupyter notebook. Oh, I need to.
I guess on Docker there is a Docker your application. There is a.
This is not. Look, this is, for instance, if you do Docker history, it shows you the commands that were used to build that image. Okay, but this is not like you're not gonna type this in. I mean, to do it automatically, I don't know actually. I don't know if there's a way. Maybe there's a way. I don't know. Yeah. Yes.
How are the security updates? Security updates.
Of your image, or?
Yes. Or when I just deploy, or just how do you
I don't know. Right now I've approached this from its development sandbox. So security right now was not a concern for this for me. And as I'm learning Docker, I have not dealt with that. But I mean, Docker is used in production now. So, but what do you mean exactly when you say security updates? Actually.
So, for example, that it turns out that one of the packages is low, then it can be exploited, and I just mean that is there a new Docker image release that you can pull and upload?
Yeah, you build a new image. Yeah.
It's like normal DevOps. But
yeah.
Simple. Just the update, like a very small virtualization. It's just a very basic system that runs. It's just all that is. And that's why also like exporting your own environment is not a good idea, right? Because for the app, you want the bare minimum requirements, so it runs as soon as possible. Normally your system is about it. So questions? If not, then we have a panel in a minute. or you can ask Sylvain after as well. So thank you. Thank you.
Thanks.